Hi, my name is Max, and today I'm going to show you Unix-based high-performance computer cluster on Azure. I already logged into my account on Azure. As you can see, I have one cloud service called Iris Azure. This cloud service has 8 virtual machines. 5 of them I'm using as a computer nodes for my cluster, and 3 of them is my management nodes. All these virtual machines are running on Ubuntu, except BlueDNS. These virtual machines are running on Windows Server 2012. We can easily connect it, and I will show you later. Azure has a really good feature called virtual network. Basically, if you run a few virtual machines on Azure and you are running them not on virtual network, then Azure can assign the IP addresses to them, of course, but also Azure can put them in different kind of boxes, even if you are running in the same location, like in this example, West Europe. So the communication between these computer nodes will be quite poor. To avoid this, you can create a virtual network, and if you do this and run your virtual machines, then Azure will put them in the same kind of box, and the communication between these computer nodes will be good. So in my case, I created a virtual network. Let's see the configuration. This is a configuration of my virtual network, and I have 4 subnets. As an example, I have a separate subnet for my computer nodes. Based on the size of the cluster you're going to run on Azure, you can create your own virtual network. In order to be able to run open MPI or any MPI jobs on a cluster, all the computer nodes should have home folder mounted to one place. In my case, my computer nodes has home folder mounted to Blue30, to my management node. As I mentioned, BlueDNS is a management node running on Microsoft Windows Server 2012. We can remotely connect to this machine, and I will show you how the DNS server is running there. It was already running. Yeah, basically we logged in into the virtual machine, and this is my DNS manager. You can see all my virtual machines and the IP addresses to these virtual machines. I would like to mention that if you shut down the cluster and start it again, then Azure can assign different IP addresses for your virtual machines. To avoid this, with the help of PowerShell, you can tell Azure that, for example, for Red 10, you'd like to book this IP address permanently. So next time, if you shut down the cluster and start it again, this IP address will be assigned to this virtual machine. It's important because if we are going to run MPI jobs, we need to know the hosts and the IP addresses. Okay, as I mentioned before, Blue30 is my management node, but also it's a login node for users. Let's log in. I'm going to log in as a user. So we log into our login node. And let's check what kind of system it is. It's Ubuntu. As you know, all the Unix-based high-performance computer cluster usually have Moab or Mao or Torque installed on a cluster to schedule the jobs. So in my case, I install Mao and Torque, so user can submit their jobs and it will be a queue and then it will run and so on. So we can check is there any jobs running at this moment on this cluster. Show queue will show us that there is no job and we have 5 computer nodes available and 10 processors because each computer node has 2 cores. Also, usually on a cluster you have a module. With the help of module you can load different programs. It's quite convenient for users, so I installed as well module eval, for example. If you type module eval available, it will show you that there is FFT, MPH and OpenAPI installed, of course Mao and Torque as well. So user can easily load the model or check what kind of environment will be loaded. So this OpenAPI, I can load this model and I can, for example, see with the help of MPI run. As an example, I prepared some simple MPI job, which is like test hello world. Let's delete the old outputs. And let's check what kind of submission script it is. We can see that I'm going to ask for 5 computer nodes. Each computer node should have 2 cores, and I'm going to load OpenAPI model, and after that I'm going to run my MPI job. As I mentioned before, it's a quite simple MPI job, just hello world. So let's run it across the cluster. Queue sub, queue run. Yeah, as soon as I submit the job, we can see that I got my ID number for this job, and this job is very simple, so it should run very quickly and should produce an output where we will see hello world from all our computer nodes. Qstart, yeah, Qstart already showed us that the job finished. If we check show queue, yeah, show queue is still showing that the job finished running, but it will finish in a sec. Show queue, start. Yeah, job finished. If we look to the output, we can see that each computer node return 2 hello worlds because it's each computer node has 2 cores, and it was running across the whole all 5 computer nodes. It could be fairly easy to install OpenFOAM, for example, but for OpenFOAM we need to have infinity connection, so the communication between the computer nodes should be good. And Azure is offering this. Basically, when you build your virtual machine, you have to choose a special type of the virtual machine, which is A9 or A10, and you will get InfiniBand connection, which is 40 gigabits connection between the computer nodes, and that is more than enough to run OpenFOAM on Azure. Thank you very much, and if you have any questions, please feel free to ask me.